How many lone pair electron dots does this molecule have right here? So I'll say right off the bat that lone pair electrons come in pairs. So that would mean that if we have an odd number of electrons in our molecule, that would mean we would have to have an unpaired electron. And that's super unstable. It's not impossible, but it's very unlikely that 7 is going to be our answer. So when relating the line bond diagram to the Lewis structure of the same molecule, you'll likely see that carbon and hydrogen are not going to have any lone pair electrons. So looking at the molecule of interest, any lone pair electrons we find in the molecule are going to be with atoms that simply aren't carbon and hydrogen. But how exactly do we figure out how many lone electrons these oxygens have? These formal charges on these oxygens is the way we're going to figure this out. Oxygen is -1 over here, and the formal charge is 0 on this one, as there's no statement of charge, so we assume it's 0. This is the equation for formal charge, and since we already know what formal charge is, and we need to figure out the number of dots, we can just simply rearrange the equation to solve for the number of dots. We make this calculation for each respective oxygen, especially since they have different formal charges, so we're going to get different number of dots, and so we got to do this calculation twice. For A, we plug in, well, first of all, oxygen is in group 6. We're going to put 6 for the group number, and they have different number of 6. This has 2, this has 1, and they have different formal charges. You evaluate that, and you get 4 dots for this oxygen and 6 dots for this oxygen. So our final molecule structure specified with the dots looks like this, and we can see it has 10 lone pair electrons distributed in 5 pairs.